Hello everyone, welcome to iitian's Gate classes. So in today's video session, we are going to see the GATE 2023 solution of Electronics and Communication Engineering for your subject Digital Circuit. So the total number of question that was asked in 2023 was 7, out of which 1 mark question there was 3 question and 2 marks question there was 2 questions. So before starting the video, I would like to say that if you haven't subscribed to our channel, do subscribe to our channel, and if you like this video, please share it with your friends. So the first question that was asked, it's a very simple question. In the circuit shown below, P and Q are the inputs. The logical function realized by the circuit shown below. So this is your 2 cross 1 mux where one of the input has been grounded and one of the input is connected to P. Selection line is connected to Q. So you have to tell what will be the Boolean expression for Y. So we know that Y is equal to, if your selection line is denoted by S, then it is S bar I naught plus S dot I1. So in this we can see that I naught is 0, I1 is your P and selection line is your Q. So if I put this in the above expression, so this will be Y is equal to Q complement dot 0 plus Q dot I1 is P. So Y comes out to be QP or PQ. So which option do we see is correct? Option number A. So the next question is a good question. The synchronous sequential circuit shown below works at a clock frequency of 1 gigahertz. So clock frequency given over here is 1 gigahertz. 1 gigahertz means 10 to the power 9 hertz. The throughput in a megabit per second and the latency in nanosecond respectively are. So what do we mean by latency and what do we mean by throughput? So latency means what is the delay. So this is basically what? This circuit. So you can see this is your synchronous counter. Okay, sorry, counter I am telling. Synchronous. Okay, so this is a synchronous counter only. Sorry. So you can see that this is what? This is your serial in, serial out. CISO type of counter means if you give a bit sequence 101, okay, so serially this one will go first in this flip flop, then in this flip flop, then in this flip flop, then it will come out. Similarly 0 will also go. So this is serially in, serially out counter. Okay, so latency means that for a single bit, suppose this one, if it has to travel from here to here, so what is the time required? So latency is given by n into TCLK, where n is the number of flip flop. So here you can see n is what? N is 3 and TCLK is what? So basically, sorry, here frequency is given to me. I have written TCLK. So TCLK is equal to 1 by FCLK. So 3 into 1 divided by 10 to the power 9. So this is 3 nanosecond. So here latency is asked in nanosecond. So you can see out of A, B, C, D, my D, C and A, all the three option has latency as 3 nanosecond. Okay. So now we have to find out the throughput. So throughput is basically what? How many number of bits are basically transmitting through a flip-flop in a second. Okay. Okay. So you can see that the time period I have calculated over here, that is 1 nanosecond. Okay, 1 nanosecond. So 1 nanosecond is required for 1 bit to transmit from a flip-flop. So in 1 second, how many bits are going to transmit? 1 divided by 1 nanosecond. So this will be 10 to the power 9 bits per second is going to be transmitted. But here in the question it is asked megabit. So 10 to the power 3 into 10 to the power 6 bits per second. So 10 to the power 6 will be mega. So 10 to the power 3 megabits per second. So that is 1000. So your option A is the correct answer. So in the next question, we have over here for the circuit shown below, the propagation delay of each NAND gate is 1 nanosecond. The critical path delay in nanosecond is. So critical path delay means what? The maximum amount of delay that occurs in a circuit. Okay. So here you can see, you can take any value. Let me take 0, 1. I am taking. So we know that for a NAND gate, if any one of the input is 0, we know that output will be immediately 1. But if one of the input is 1 and another input I don't know, this is x, so I need to wait for this another input to determine exactly what will be my output. So here it will be x complement, which depends on this input. But if it is 0, it doesn't matter if another input is 0 or 1, immediately I can say that output will be 1. So here in this flip-flop, let this, sorry, flip-flop I am telling, in this gate, let this be 1 and let this be the second gate. So in the first gate, input is 0. So immediately after 1 nanosecond, output over here will be 1. Okay. So after 1 nanosecond, and this one, it will be transmitted to this over here, as because in the second NAND gate, one of the input was 1. So for determining the output, I need to know the another input. So this one, it came after, it was generated after 1 nanosecond. So output over here will become 0 after 1 more nanosecond. That means 1 nanosecond for this input and 1 nanosecond for processing both the input to get 0. So in total 2 nanosecond. So the critical path delay is what? It is your 2 nanosecond. So the next question asked is, a sample and hold circuit is implemented using a resistive switch and a capacitor with a time constant of 1 microsecond. So time constant of a RC circuit is what? It is 1 microsecond. The time for sampling switch to stay close to a charge a capacitor adequately to a full scale voltage of 1 volt with 12-bit accuracy is. So basically, if you want to draw the sample and hold circuit, so here we have our input and from here we are taking output. This is R, this is C. Okay. So basically you have to find in this question that for how much time this switch should stay closed to charge a capacitor adequately. Okay, adequately, so that I get a equivalent voltage. So now here we know that full scale voltage is what? It is equal to 1 volt, and step size is equal to what? Step size is 1 divided by 2 to the power n minus 1. So here it is a 12 bit. So this will be 1 divided by 2 to the power 12 minus 1. So 2 to the power 12 is 4096. So this will be 1 divided by 4095. Okay, so this is your step size. So for a single step, what will be the voltage? 1 divided by 4095 volt, whatever this will be. Okay. So now see basically that how much time this switch should stay closed, okay, so that it can properly detect the voltage. So for 1 volt, you can see, means understand like this, okay. So let this be 12 bit, so 0 0 like this, 0 12 bit, and the last one will be what, 1 1 1 like this for 12 bits, okay. So at this position I should get what, I should get 1 volt immediately at this step. So what should be the voltage? It should be 1 minus whatever is the step size voltage. You can see for one step it is 1 divided by 4095. That means from here to here your capacitor voltage should be greater than this value. It should be greater than this value so that it can differentiate between this step and this step, okay, between this one and this one. If my voltage is greater than this one, then immediately it will consider this step, okay, and if it is less, so it will take. So the minimum voltage for this last step to be taken, or for the last step to be determined, it should be greater than, means the capacitor voltage should be greater than this value. So your VCT, it should be greater than 1 minus 1 divided by 4095. Now what is this capacitor voltage? This is a charging capacitor, okay, this is a charging capacitor, and for charging capacitor we know the transient equation. I can write it as Vc infinite plus Vc0 minus Vc infinite e to the power minus t by tau. So Vc infinite, see, if I have kept this switch closed, if I had kept this switch closed, so I will get 1 volt, okay, infinitely if I keep it, so 1 volt I will get. And initially the capacitor is what, as this is a sample and hold circuit, so the capacitor should discharge immediately, okay, once the switch is open. So Vc0 is equal to 0. So if I put this, and tau value it is given, so if I put this expression, so this will be 1 into 1 minus e to the power minus t by tau. Okay, so time required here is also in milliseconds, so I will keep it like this. So this should be greater than 1 divided, sorry, 1 minus 1 divided by 4095. So if I solve this, you can see e to the power minus t is equal to 1 divided by 4095. So this will be ln. So t is equal to ln 4095. So if I solve this, you will be getting 8.317 microseconds. So this is your answer. Okay. So this was also a good question. So the next question, means if you see, so this is a very simple question, but here actually something, there was some kind of confusion, due to which you will see, if in the solution, if you see in the answer key provided by IIT, there are two answers. So one of the answer, I think it is 250, another is 500. So let us check how do we get this two answer. Okay. So in the given sequential circuit, initial state Q1 and Q2 is 10 for a clock frequency of 1 megahertz. So clock frequency given over here is 1 megahertz. The frequency of signal Q2 in kilohertz is. you can see this is what, this is your synchronous counter. If this was asynchronous counter, immediately you could have said that Q2 will be what? It will be 0.5 megahertz. You could have said that because this is the second stage. Okay, but this is your synchronous counter, and in synchronous counter, basically your clock frequency, frequency of this any one of the flip flop, it is actually equal to f clock divided by n, where n is what? N is your mod number, means how many states are repeating, how many unique states this counter is generating. Okay, so if that is the case, so you can see Q1, let me write the next state equations of these two flip flop. So Q1 plus, it will be equal to D1, and D1 is actually equal to Q2. Okay, Q2. And Q2 plus is equal to D2, which is equal to Q1 complement. Okay, Q1 complement. So if this is the case, we got this one. So now over here, let me write the clock, and over here, let me write the states Q1, Q2. So initially Q1, Q2 is 1, 0. Now we know what? That in the next clock cycle, whenever we get a so this is a positive edge triggered flip flop, positive edge triggered counter. So in the next positive edge, you can see Q1, it will be equal to Q2. So that is 0. And this will be Q2 will be Q1 complement. So 0. In the second case, so this will be Q2 means 0. This is 1. In the third, so this will be 1, this will be also 1, and in the fourth, so 1, 0. So you can see the number of unique states. You can see over here, how many are there? So there are 4 unique states. 4 unique states over here. So if I draw like this 1, 0, then in the state diagram we have 0, 0, then we have 0, 1, then we have 1, 1, and once again this is repeating. So this is a mod 4 synchronous counter. Okay, mod 4 synchronous counter. So the frequency will be what? Here I have 1 megahertz. So 1 megahertz means, here I want answer in kilohertz. So 1 megahertz means 1000 kilohertz divided by 4. So this is 250 kilohertz. Okay, 250. Now how do we get 500? See, basically here in this question, D2 is basically what? This output is Q1 complement, but here you can see there is a bubble. So due to this bubble, there was this confusion that this complement and this bubble is actually cancelling out. Okay, so if I take that case, then next state equation will be Q1 plus is equal to D1, which is equal to, you can see Q2, and Q2 plus is equal to D2, which is equal to what? You can see this I have taken from complement and this is bubble. So bubble and complement will cancel each other. So this will be Q1. So Q1, Q2, and let there be clock. So initially this counter was initialized with 1, 0. So 1, 0. So in the next case, so in the next positive edge, you can see this will be 0 and this will be 1. In the second clock edge, this will be 1, this will be 0. So repeating states I am getting once again. So the number of unique states are 2. You can see. So the state diagram, it will be like 1, 0, then 0, 1, and this is keep on repeating. So this is a mod 2 counter. So for mod 2, basically the frequency of any one of the flip-flop, it will be FCLK divided by 2. So that means 1000 kilohertz divided by 2. So 500 kilohertz. So for this particular question, both the answers were acceptable. But if you ask me which one of them, if suppose in your examination, if there is once again such kind of question, then which one you have to consider? You have to consider this one only. Okay, you have to consider this case only. So with this, we end this session. If you like this session, please put a thumbs up and share this with your friend, and kindly do subscribe to our channel. Okay, thank you.